of these ceiling tile spaces, move it over by 1. That was enough. It increased the task level slightly, which made people happy, and it also reduced the light level on the wall, and that was enough. In other places, we had like 4 fixtures in there. We were able to take 2 of them out, and the other 2 were still bright enough, and we got rid of the excessive wall lighting in that room. These are small rooms where we had this problem, or very narrow rooms. Most large rooms, nobody notices. But the answer is, yeah, you could paint the walls if you want. Look for any kind of glare, any kind of excessive brightness within the visual field, any kind of visible LEDs, that's going to create glare. You'll see that upstairs in a minute. Any major change in coloration of furnishings. Do you have products? Do you have people? Do you have something where the change in color from being nearly perfect to being slightly less than red, does it make a difference? All these things you want to do in a test room. And ask people to try it for 2 weeks. If in 2 weeks, usually what they'll say is, now it's fine, goodbye, don't bother me, I'd rather have a raise instead. What's the next issue of the office? And then the lighting becomes secondary. If there's still a problem after 2 weeks, then you want to think about making changes to keep everybody happy. And especially, we're going to get to the dimming now, especially you want to plan for the future. If the existing foot candles and distribution are fine, don't screw with them. All right, leave them as is. But consider the future uses of your facilities. You may wish, for example, to engage in what's called demand response. Who here can tell me what demand response is? Well, you really ought to know this stuff. Okay, demand response, very important. This is where if you reduce your electric load at certain times of the day or upon being called by the utility or the grid, they will give you money for doing a slight reduction in load. Because at the wholesale market, electric pricing goes up exponentially as the supply and demand get close together. So in a chart that I use in another class, if the normal price for electricity wholesale is like 5 cents a kilowatt hour, the load on the grid goes up by 10 to 20%, that 5 cents a kilowatt hour goes up to 50 cents a kilowatt hour. It goes up exponentially. So at that curve where it goes up, if you can reduce on the grid a little bit of the demand on the grid, you see a big drop in price. Demand response is designed to do that. It's been around for about 15 or 20 years. If you've got a facility where you can do a little reduction in light output, a little bit of dimming, you can do that and bid it into demand response so that maybe 20 hours out of the year, spread over a whole year, you do that slight dimming and the utility will pay you money. That's demand response. That's one level of dimming. The other possibility is that your usage of the space may change. Almost before I do that, what's daylighting? Marilyn, you know what daylighting is. Tell us.
Yes.
You know this. Come on.
Yes, well, light comes in the windows, you turn off your electric light.
Right. The idea is if you've got enough light coming in that's natural, there'd be a sensor in the fixture or somewhere in the room which would gradually dim down the lights so people don't notice it. And when they dim down, there'll still be enough light on the task because you're combining daylighting with electric lighting. That's daylighting. That will save you more kilowatt hours. It may not save you any kilowatts. That's how fast you use electricity. But the deal is that way you can do even greater reduction in greenhouse gas emissions. Now, some of these don't dim. Most of them, as a matter of fact, if you want dimming TLEDs, you will pay more for them. Almost all of the retrofit kits that we looked at have built-in dimming capability. All of these do. If we wanted to, we could dim every one of these if we put a dimmer in and connected low voltage wire to either of them. It's called 0 to 10 volt wiring. So we, in our facility, designed it so that in the future we can do demand response or daylighting, because where most of these were located is usually near windows, and thereby either do more reductions in greenhouse gas emissions and or participate in demand response to get even better bang for the buck than we did. Right now it's not cost effective because the electric rates for New York Power Authority are sufficiently low that it's a really long payback and we don't have the money. But we put these in so we can do them in the future. Well, time for a funny story. The answer is yes, it can be an issue. And if anybody moves any furniture around, that can confuse a daylight sensor. The biggest joke I heard about this was in a room where they had vertical partitions and they had some people working and they had the daylight sensor pointing straight down. And it was fine for the person who was working directly underneath. She had long, dark hair. Then a guy moves in that same room who was totally bald. When the daylight sensor saw his head, it said, "Oh, lots of light in there, it's bouncing off." And so therefore, we can turn the lights off in this room, all because of the difference in the reflectivity. So the answer is yeah. Normally what you do, without getting too technical on daylighting, is you have an outdoor sensor and an indoor sensor. They work through a little computer to figure out what's really going on in the room as versus what's coming through outdoors. And that's the best way to do it, but that will add a lot of cost. Daylighting makes the most sense if you're doing a whole renovation of a space and can take that into account. And daylighting also works best if, when the light comes in, you're able to distribute it further in to the room. Normally, when you have light coming in from outdoors, maybe the first 10 feet is where that outdoor lighting is going to come in. Anything deeper into the space, it may not make it. However, there are light shelves that can be put in. So if this is a window in a room, you put like a flat surface. Light comes in, it strikes it, it bounces up further into the room off the ceiling. That requires an architectural change and usually a higher ceiling. So when you're doing a whole new space, think about daylighting and how you can put these light shelves in to spread the light out, and then you'll get a much bigger bang for the buck, and it'll also even out the light more overall. So I say daylighting, great idea. I did my first daylighting at Columbia in 1996. That was a touch and go. They had nice big windows. And there, it basically turned them off or on, and that was too much for people to see. And they'd say, oh, their lights are on and my lights are off, even though they're getting plenty of light from the outdoors. We said, oh, but their lights are off. Why are my lights off? And the answer was, look, the foot candles are the same. Well, that's not the same. They got lights and I don't. So part of the answer was, fine, leave everything on. So it's touch and go on daylighting, best in new buildings or new spaces. Okay, let's finish off, and then we'll go upstairs. Almost done. The other changes you may have is you may find that in a large room, like a cafeteria, which is what this used to be. This used to be the cafeteria. This was a school before, right? They came down here, this is the lunchroom. For large spaces like this, if this became a computer lab, you might want to go to a lower light level or to indirect lighting. Or suppose, for example, to turn into a conference space where you had to have the ability to dim in order to do film presentations, whatever. You want to think ahead of time. Here, if we wanted to, we can dim these if we want to. All these are dimmable. We don't have them hooked up that way because it would cost a lot of money, but we have that ability built in. What you want to think about in today's equipment that you're going to buy is tomorrow's needs. Keep them in mind. Don't paint yourself into a corner. And now to summarize, as we come up to our hour and a half, what did we choose? We looked at putting in the simplest for us to be able to fit within the budget and still maintain the light levels and work with our existing fixtures, which initially were parabolic louver fixtures. We took out the parabolic louvers. You'll see them still out in the hallway. That's the 30% we didn't touch, and put these flat guys in. That widened the beam spread, gave us a much more natural look, and also gave us the ability to dim. We were lucky that the ballasts, when we started out, were all instant starts, and the sockets were all unshunted. So it made it very easy to pick out what we wanted because everything was the same, except for a dozen fixtures where we had to put in whole different odd things. We put in the type 2 AB TLEDs in 30% of the space. They go in as a type A, just plug and play. When the ballast conks out, the fixture gets rewired, and this goes back in. That hopefully won't happen for many years because the ballasts are still relatively new. At least some of them were. The other 70%, of course, we used these flat plate retrofit kits. I mentioned that. I'll go in here. Okay, this saved us enough grant money by picking and choosing what makes the most sense for each space. So we saved about $10,000 out of a $50,000 budget. Those $10,000 are now going to get used, with NYSERDA's permission, thank you, in a new Department of Public Works garage and office building that we bought. It's a used building, which has in it many 150-watt incandescent downlights, which are all going to go bye-bye. They're all going to get replaced with LEDs, plus a bunch of these and some of the Type ABs, depending upon the usage that we expect to use in those spaces in the future. That will reduce the total wattage, total greenhouse gases, greater than what we have in our little booklet, because at the time we printed this, we weren't sure if we were going to be able to do that work in the garage, which has already started and should be finished in a couple of months. So, in Croton, this is how we try to make sustainability happen. Those of you that are not in Croton should know we're very proud of our waterways, our waterfronts. We've got lots of people with boats, lots of parks. This particular situation right here is one of our parks. That's part of the New York City watershed system. It's about 2 miles from here. It's called Croton Gorge Park. And it's our belief that this is the way we make LED happen. It's part of a project in an overall process. And once again, we thank NYSERDA for making this happen. If anybody hasn't already got a copy, you can get a PDF copy of these slides and the brochure anytime. You can also email us at info@sustainedcroton.org, and we can send you more information on what work we've done. Yes?
How would a municipality or any public agency, for that matter, that doesn't have the benefit of your expertise?
Best thing to do is usually work with somebody who has lighting design experience. We have one particular person here from Energy Efficient Lighting Design who does some of this kind of work. Do any of the others do lighting professionally? Okay, there are lighting designers out there that will come in and basically handle the whole thing for you under contract and work with you to develop the specs that meet your needs. That's the best way to go. In my case here, as I say, I've done over 20 million square feet of these things. And also I was very interested in the technology, so I got into it.
And our
Yeah.
light,
Ask for references, see projects that they've done.
thank you.
There's also a test that they can take. Not everybody has done this, but the IES, which is the Illuminating Engineering Society, which is the big dog in this whole thing, they have something called the LC, which is lighting certification, right? And usually somebody in a company that's doing this should have taken the LC test, at least one of them, and passed it. It's not a hard test. I wrote part of it. So if they can do the LC, they've pretty much got their act together. There are also other ones. There's called the CLEP, which is the AEE's Certification in Lighting Efficiency Program, or CLEP, from the Association of Energy Engineers. If they've taken that test, CLEP test, odds are they're going to be pretty good as well. But they should have been able to show that they have some smarts and be able to pass a quiz. If they can't do that, get somebody else. There's plenty of people out there that can help you on this stuff. And no, I didn't mean to scare you with this, but just so you're all aware, it's like your inoculation to now knowing about this. Question?
Is your contact info?
info@sustainedcroton.org. It's on the last page. Yeah.
You had mentioned before when you dim an LED light, you have to run this low voltage wire.
Okay, the way it works, there are different ways to do things. The typical standard way of doing dimming is what's called 0 to 10 volts. What it means is that if this is the ballast that controls everything, it's got wires going in that put out power to the lamps. There's also some very low voltage wires, like really skinny wires. They're purple and black, or purple and brown are the dimming wires. They're two different color wires, and they're real skinny wires. They only have 0 to 10 volts passing through them. The amount of voltage it passes through is proportional to the amount of light you want. That goes back to a dimmer that you might have on a wall, or to a daylighting doodad in the ceiling, which will say, I want more light, I want less light. It will send out that signal, 0 to 10 volts, to the ballast. The ballast will then take the power, normally at full, send it out to the lamp, and dim the light down, up and down. So 0 to 10 volts is the standard. There's also, what's Lutron called? Just Lutron? Echo, they call it. There's some other brand names of doing this, which have it done differently, which are very nice, very precise, but they cost you an arm and a leg. 0 to 10 volts is pretty much the standard, and for all the retrofit kits I've seen of LEDs, all of them use 0 to 10 volts. Do you know of any other? They're all 0 to 10, right? Yeah. There may be some others that have other things, but the cheapest way to do it is 0 to 10 volts, and almost all these new kits, they're designed and they come that way. Other questions before we go upstairs? Yeah.
Well, can you use an AC dimmer on those? Or
Okay. The dimmer has to be compatible with the ballast you've got in there. So I'll simply say that if you've got first of all, you have to have a dimming ballast. If you don't have a dimming ballast, nothing will work.
well, I was talking about
Oh, the ones that bypass. Let me think for a second. The answer is yes. There are some that I've seen on a standard AC, which can also be used for incandescent. Some of them will work with those dimmers, but you better make sure that it actually says that in the specs. And here's the other thing. For those, when you turn them down, it's not linear, which means you turn it down halfway, nothing happens. You turn it down 10%, light dims a lot. Last 10%, nothing. So you want to test it with your actual dimmer on just like a few fixtures and see how well it works. Because a lot of these guys put in information about this, which is not quite real, and they just want to sell you something. So
usually you don't get the full brightness.
right, you didn't get the full brightness. Test it with your dimmer and see what happens. That's the best way I can tell you now.
Because I noticed we put some LEDs in and the light feels gray almost.
Well, get the kind of lamp you're thinking about, test it in several fixtures. That's really the only way at this point you can be absolutely certain is to test before you invest. Okay, let's go upstairs to the second floor, show you what things look like up there. If we look at this wall, it looks slightly greenish, and it's under the normal fluorescent lamps, which put out a certain amount of red color. Now, if we turn around and look at the same color wall as lit by the LEDs in that corner, you'll notice it is somewhat more bluish, less greenish. That's because the LEDs are lacking in some red that is in fluorescent lamps. The result being that in some cases the lighting quality for LED may be less based on color. Now, we can see some specular, that is to say glossy reflection off of this picture of the individual LEDs lit from the fixture above, because the fixture above and the LED lamps do not have any kind of a diffuser in them. This is usually considered the lowest quality for LED lighting because it can, off of any kind of specular glossy surface like marble or glass or whatever, show those individual LED chips lit, which can be a distraction to people in an office or other areas. Now, what we see on the wall with these like light and dark strips, these are called lighting artifacts. This is due to the fact that there is no diffuser to smooth out the light distribution from the tubular LED lamps. This is also not acceptable. Good LED lighting does not show any such variations on the wall. We're showing it to you here, again, to show the lowest quality of LED lighting and how we have done much better by making this even, as you will see later on further down the corridor. It may be hard to notice, but because of the narrowed beam spread of the TLEDs, the tubular LEDs, they have narrowed the distribution of light on the floor so there are dark and light patterns between each fixture. Normally we would have the floor lit completely evenly, and now we've actually narrowed and widened the beam spread such that we have some change in the distribution, which is really not acceptable in any kind of professional way. Fixture number 5, we have relatively low flicker. You can see it's in the green zone. This is where it ought to be. What we found during our studies was that 4 out of the 10 units we installed had flicker much higher up, which was unacceptable. We were able to get some of the manufacturers to change their products and improve them so that the flicker would go away. This flicker is not visible to you. It's at 120 cycles per second. But some people that have what's called photoepilepsy and others who have children with autistic behavior can have some problems with headaches and behavior problems when we go out of the green zone and into the yellow and the red, which we will do when we go to fixture number 6, which we maintained having the flicker in it to be able to do this demonstration. Now, one other thing I'm going to do, hold on, is I'm going to show this ballast discriminator. Hold on. You see the green light above my thumb? Okay, that indicates very low flicker. Now this is fixture number 6. You can see how much higher the flicker is measured on this flicker meter, which shows us the percent of flicker. It's way into the orange zone, which indicates it's not acceptable. We kept this one in here just so we could show the difference. Again, this flicker is not visible to the human eye. This device here shows the flicker in a different way. You see the red? That indicates that we are seeing flicker at 120 cycles. The most crude way to do this is through the flicker wheel, which under this fixture, if we do the spin, you should be able to see the same kinds of patterns as we showed downstairs when we tested with the 2-foot light, the short light. Can you see the pattern on the wheel? That indicates, once again, we have unacceptable flicker at the 120 cycle range. That's our LED show. Thank you very much for your time and attention. We hope that you enjoyed it.